So our objective, we want to, I can graph and analyze absolute value functions. And I think the best way to look at this is to kind of jump into an example. So we're just going to say we have f of x is equal to the absolute value of x, which should be easy enough. Let's go ahead and make just a table with a few values. So here's our x, and here's our f of x. We used to always call this y, right? So f of x or our y. If our x, let's start in the negative. So -2, -1, 0, 1, 2. And f of x, if it's the absolute value of x, the absolute value, remember, of -2 is a positive 2. Absolute value of -1 is a positive 1. Absolute value of 0 is still 0. Absolute value of 1 is still 1. Absolute value of 2 is still 2. And if we were to graph this, so let's create a little axis here. If we were to graph this, start at our y-intercept, which is 0, 0, and let's just graph these points. So if x is -2, so maybe put some marks on here. Guess I only have to go up to 2. If x is -2, then y is +2. So we'd have a point right here. If x is -1, y is +1. So we have a mark right here. If x is 0, y is 0, so we're good there. If x is 1, we're also at +1. And if x is 2, we're still at 2. And so if we were to, and this is just a sketch, but if we were to draw these out, then we get this V thing. And previously, when we do our graphs, we just have a straight line and it would just keep going into the negative, right? But with absolute value functions, we're just talking about the distance from a certain point. And so if it's, so we're looking for a distance. And you're not ever going to say, well, I'm -3 miles away from something. You would say, I'm 3 miles away from something. And it doesn't matter which side of that location you're on, you're still 3 miles away from it. Okay. So with the absolute value function, we get something like this. It can be in the negative, but only if there's something on the outside of the absolute value that gives you that negative. Along with the absolute value function, there's something called the axis of symmetry, and I'm going to use a different color to kind of point this out. We'll use a nice orange color. So the axis of symmetry is the line that is symmetrical, that makes this symmetrical. So in this case, it is the y-axis, right? So if we were to kind of put this and pretend it was a mirror, this is our axis of symmetry, meaning this side and this side are symmetrical. Okay, so that's our axis of symmetry. It goes right down through the middle point, which also has a name, and I'll tell you that in a second. So this is our axis of symmetry. And it goes through this point right here, which is called our vertex. Yes, in this case it is the origin, but it doesn't have to be. And if we had a y-intercept, it wouldn't be. But we have, it's on the origin this time. But that's called the vertex. It's the center point where the axis of symmetry crosses. Okay, and that's just the introduction to this. Hopefully that helps. There is one other video that is an example. So go ahead and watch that one as well, and then I'll probably try and throw up another example or two as well.